before yesterday, I had uploaded some videos regarding lasers. So by the request of some of the students, I had a plan to give some key points to the chapter lasers, and in addition to the notes what the HOD sir had uploaded. Looking at the notes and by my video lecture, you will feel comfortable preparing your own notes. So let me clarify some of the doubts, and we will take the session in two parts. So the first part of the unit 4. Now we are discussing unit 4, and the unit 4 name is lasers and fiber optics. Lasers and fiber optic. So first we will try to complete the first part of the chapter, or the first part of the unit, that is called lasers, right? So this laser, this unit, a laser, is an important application in the field of engineering and technology. So in 1961, so let me start the introduction. As in our class, first we'll be starting our introduction. In the introduction, in 1961, Albert Einstein invented a laser. So no scientist directly invents an event or invents an effect. So first he observes an important parameter in the word laser called as stimulated emission. So stimulated emission. So this stimulated emission led to the one of the important tool, or one of the important weapon for the engineering and technology called as laser. Right? In detail, we will be discussing what is stimulated emission, why the name laser. Right? So, listening my lecture, you slowly start to concentrate on important terms like stimulated emission, like that. The acronym means the acronym of laser. That is, acronym means full form or the abbreviation. As we know, familiar, like a LED, light emitting diode. Similarly, a laser. Laser is light, L for light, so A for amplification by an important process called as a stimulated, E for emission of radiation. Radiation means energy. That energy is the light energy. You know that the radiation is of different forms, and that radiation in our present context is light. So light amplification by stimulated emission. This is an important parameter in our throughout the unit 4, stimulated emission of radiation. Right. So you know that the simple definition and simple concept of light. Then we have to know the word what is amplification. Amplification, I will simplify the word amplification by your mathematical concept like multiplication. Here the light will be multiplied. Sir, how the light will be multiplied? Is there any calculator that which multiplies light? No. So there is a phenomena that a light will be multiplied, means the light is in the form of photons, and the photon number will be multiplied. For example, in the first step I will get a single photon. That single photon will be multiplied into 2 and multiplied into 4 and 8 and 16. So on. This will be amplified. Amplification means becoming huge number. Okay, so that photon number will be multiplied step by step, and that multiplication process will be done by a stimulated emission, by a process stimulated emission, and that huge light, that enormous amount of light or the enormous amount of intensity of photons will be radiated. That parameter made the laser applicable in many fields like engineering and technology. You know that now by the in the medicine also, by the contact lens, and in the chip designing, and in the barcode reading in shopping malls, and so many applications are there in the laser in order to remove the unwanted hair from, and also for the uproot of the rooting of the hair also, and also the uprooting of the hair also. So in many applications, therefore this became an important tool for the engineering field. So let me go for the once again the repetition of the laser. So the light amplification by stimulated emission of radiation. Amplification is nothing but the multiplication. So the photon number will be multiplied by a process called as stimulated emission. So let me go in detail. So what is the emission and what is the absorption? So this all comes under the introduction part, right? So before going to discuss the word stimulated emission, let me introduce the word before the emission. Let me introduce the word absorption, the opposite name of emission. Absorption. In general, there are large number of atoms. There are large number of atoms in the ground energy level. This is a simple concept, a ground energy level. This is a simple concept which you are very familiar, because almost all the atoms occupy ground energy level because due to in order to attain stability. So in order to attain this stability, most of the atoms in every solid, if you take, the atoms occupy large number of atoms in the ground energy level in order to attain stability, because the solid must be in stable state, so without any excitation of over energy. So therefore, so if I go for the diagram, so let us consider, so this is a ground energy level, and I will represent it with E1, that is called as a ground energy level, or a lower energy level, also called as a lower energy level, a least energy level. And obviously in an at some state there will be higher energy level, which I represented with the E2, and this is called as higher energy level, right? So if I go for a rough diagram, so these are the atoms, and all the atoms will be occupying the ground energy level. So all these are atoms. So this is the occupation of the atoms in the ground energy level in order to attain the stability. Every solid prefers to be in this state only. It means occupying in the ground energy level. This makes the solid to be very stable. In this situation, in this point, let me introduce some external energy like light. So this is an external energy. So this external energy I am taking in the form of light energy, photon, whose energy already you know, that is, it is hnu. So when this hnu, are also called as a photon, is incident on the ground level atoms, so these ground level atoms absorb the energy. So these ground energy level atoms absorb the incident photon. This hnu energy will be totally absorbed by the ground level atoms. Ground level atoms all will be absorbing the incident photon. So this is a photon, so this is a photon, this is a photon. These photons will be absorbed by the ground level atoms. And as a result, the atoms, as their energy is extra, the atoms will be excited to higher energy level. So this is the process. As the energy is extra, that is, as we have supplied some external energy like photon, hnu, and these photons will be absorbed by these atoms, and these atoms, as they are possessing enormous energy, as we had supplied, they doesn't be in the ground energy level. They automatically jumps to higher energy level. So this atom will be jumping to higher energy level atom, and this atom also will be jumping to higher energy level atom, and this atom also will be jumping into higher energy level atom. Like this, the process continues. So this is the step. And as the atoms are absorbing energy and exciting to higher energy level, hence the name, or hence the process is known as absorption. So let me write a word here as the atoms are absorbing, as the atoms are absorbing incident energy, the process, this process is termed as absorption. So this is a basic step where you have to know the meaning of absorption before getting into the word emission means. Emission గురించి తెలియాలి అంటే ఖచ్చితంగా absorption గురించి తెలియాలి. So therefore I have introduced the word first absorption means. So let me revise some important points in the absorption topic. Let us consider a solid, and in every solid there will be large number of atoms in the ground energy level. So why? Because in order to attain stability, that is a universal factor. So when such ground level atoms are supplied by an external energy like a photon whose energy is h nu, the ground level atoms absorb this external energy and jumps to or excite to higher energy level E2. This process of absorbing energy is known as absorption, right? So now let me go for the opposite term of absorption. The opposite term of absorption is emission, right? So let me go for the next topic, that is emission. Then what is this emission? So previously I said that some atoms are excited to higher energy level. So this is higher energy level, and say this is a lower energy level or a ground energy level and all the atoms will be excited, and there will be some or two here in the ground energy level, and these atoms are excited. Now these are said to be higher energy level atoms, and these atoms are said to be ground energy level atoms. And these excited atoms doesn't stay for a long time. They almost stay for a time of 10 power minus 8 second only, which is a very, very, very microscopic time. If you look at the number, that is 10 power minus 8 second. So this time, up to this time, they will be existing in the higher energy level. This time is called as a lifetime వరకు అక్కడ ఉంటాయి. అంటే 10 power minus 8 second వరకు అవి హయ్యర్ ఎనర్జీ లెవెల్లో ఉంటాయి. అండ్ ఆఫ్టర్ 10 power minus 8 second, without any external aid or without any external help or without any external source, they automatically jumps back to the ground energy level. They automatically de-excite. They automatically de-excite to ground energy level. So when de-exciting from higher energy level to ground energy level, any atom or any molecule or any electron, when de-exciting from higher energy level to ground energy level, so they have to lose their energy, because here higher energy level they will be having extra energy, ground energy level they will be having a lowest energy. So obviously and automatically they have to lose some extra energy which we had supplied in the previous process of absorption. Absorption లో మనం సప్లై చేసిన ఎనర్జీని ఖచ్చితంగా అవి కోల్పోతేనే, అవి లూజ్ అయితేనే అవి కిందికి దిగుతాయి, అంటే గ్రౌండ్ ఎనర్జీ లెవెల్కి వస్తాయి. ఇన్ ఆర్డర్ టు de-excite to the or attain the stability, why they are reaching the ground energy level? And once again the question and the answer, you know that the ground energy level atoms will be having more stability. So as a result, the higher energy level atoms de-excite to the ground energy level atom by emitting the energy. So this is how the energy will be emitted. So this is the process of emitting. What we had supplied is we have get back. సో మనం ఏదైతే ఇన్సిడెంట్ ఎనర్జీ ఇచ్చామో ఆటోమేటిక్గా అబ్జార్బ్ చేసుకుంది, వన్స్ అగైన్ ఇట్ ఈస్ గివింగ్ బ్యాక్. అండ్ దిస్ ఈజ్ ఎమిటింగ్, ది atom is emitting this photon, this atom is emitting this photon, and this atom is emitting this photon. So all the higher energy level atoms are emitting the energy what we had supplied. So this process, the process of emitting the energy is known as emission. So this emission is exactly an opposite word to the absorption. In the absorption, it has absorbed the energy, external energy, and in emission it has a emitting what it has observed, it is giving back. So this process is known as emission. So now let me go for, so now this is the process of emission.